Okay, so hello and welcome. We are here again. We're going to look at the problem exclusive time of functions. And let's get right into it. Another LeetCode problem. I think I have oh, you know I did something wrong. Hold on. Sorry. Give me a moment here. Okay. Yes. This is what we want. Alright, here we go. Exclusive time of functions. Let's see how this goes here. Also, my body. Okay. Exclusive time of functions. Oh, it's got a lot of downvotes. This is going to be hard. Okay, it's going to be hard. A single-threaded CPU, we execute a program containing n functions. Each function has a unique ID between 0 and n-1. Function calls are stored in a call stack. When a function call starts, its ID is pushed onto the stack. When a function call ends, its ID is popped off the stack. The function whose ID is at the top of the stack is the current function being executed. Each time a function starts or ends, we write a log with the ID, whether it started or ended in the timestamp. You are given a list logs, where logs of I represents the ith log message formatted as a string. Function ID start end timestamp, for example, 0 start 3 means there's colon between these parts. Start end timestamp. Okay. For example, 0 start 3 means a function call with function ID 0 start at the beginning of timestamp 3, and 1 end 2 means a function call with oops. Oh, I've got Spencer Smith over here. I like this, the Spencer. Yeah, 0 start 3 means a function call of function ID 0 start at the beginning of a timestamp 3, and 1 and 2 means a function call of function ID 1 ended at the end of timestamp 2. Note that a function can be called multiple times, possibly recursively. Okay, I don't fully understand what I'm reading here, but I'll read it a few more times to get it. Functions exclusive time. How are we doing on time, by the way? 2 minutes, okay. Functions exclusive time is the sum of execution times for all function calls in the program. Functions exclusive time is the sum of execution times of all function calls in the program. For example, a function is called twice, one call executing for 2 time units, and another call executing for 1 time unit. The exclusive time is 3. Return the exclusive time of each function in an array where this value at the ith index represents the exclusive time of the function with ID I. So they want an array of values. They want an array. So I don't know what I just read. Somewhat biased by the fact that I got a lot of downvotes. So I'm kind of assuming that it's going to be. Usually that's one of the reasons why it gets a lot of downvotes. It's hard for some reason, and then oftentimes the reason is just hard to understand. Yeah, or there's a lot of edge cases too. It's another issue. Okay, so n equals 2, or sometimes they just explain it in such a way that it's like basically it doesn't quite match the explanation. So 0 start, 1 start, 1 end, 0 end. N equals 2 log 0 start 0, 1 start 1, 1 end 5. 0 start 0. So the first value is the ID. The second value is the timestamp. So this is the first function starts at 2. First function ends at 5. Oh, I see. And then the second function ends at 6. So the output is 3, 4. Function 0 starts at the beginning of. So the exclusive time is. What is the exclusive time? Sum of execution times for all function calls in the program. For example, a function is called twice, one call executing for 2 time units, and another call executing for 1 time unit. Exclusive time is 2 plus 1 equals 3. Not fully understanding here. Explanation. Function 0 starts at the beginning of time 0, executes for 2 units, of time and reaches the end of time 1. Function 1 starts at the beginning of time 2, executes for 4 units of time, and ends at the end of time 5. Function 0 resumes execution at the beginning of time 0 and executes for 1 unit of time. So function 0 spends 2 plus 1 equals 3 units of total time executing. Okay. And function 1 spends 4 units of total time executing. Okay, I think I get it. This is going to be kind of hard to program, though. This is like kind of involved. I think the stack-based question, I think overall it's probably not a hard question conceptually, but it is definitely hard to parse like what the meaning is here, and then also probably coding it probably requires something kind of tricky. So input n equals 1, logs 0 start 0, 0 start 2, 0 end 5. So this is kind of weird. So you start at 0, but then you start again at 2, and then you end at 5, and then you start at 6 and end at 6 and end at 7. So that's really confusing. What's going on here? Yeah, so I guess it's kind of could be, I don't know what the inputs, if they have any order to them. Like, can you end before you started, and does it matter? I mean, does it matter how these inputs are ordered when you get them? Do you need to order them yourself? I mean, I could sort this. Probably first thing to do is parse these inputs into objects that we can sort, like tuples, probably in C++. Function 0 starts at the beginning of time 0, executes for 2 units of time, and recursively calls itself. Function 0 recursive, oh boy, oh brother. Come on, man, really? Really with this? I didn't mean to click that. Whoa, what's that do? What did I just do? Clicking the wrong things. What is that? What does this say? Click this button to save in Firefox. No, I don't want that. And then I also managed to open my Notepad++. Okay, just clicking around, but recursive call starts at the beginning of, what did I want to do? I wanted to, I don't know why I was clicking around in the first place. Oh, I wanted to check the chat, yeah. Function 0 recursive call starts at the beginning of time 2 and executes for 4 units of time. That's so confusing. So now it's a recursive call. Okay. Executes for 4 units of time. Function 0 initial call resumes execution, then immediately calls itself again. Okay. So I guess I think I know what to do, but basically I think we sort on. Oh, this is so confusing. I guess it's the point of the question. Function 0 second recursive call starts at the beginning. Oh, okay. Function 0 second recursive call starts at the beginning of time 6. Executes for 1 unit of time. But it ends at 6, ends at 7. Function 0 initial call resumes execution at the beginning of time 7 and executes for 1 unit of time. What is going on? That is so confusing. Oh boy. Oh boy. Okay. First call, recursive call. Now does this end? This ends the second recursive call. No. So this call executes for 4 units of time until we get to 6. The second call, yeah, the first call ends at 5. 2 units, calls itself. This begins at time 2 and executes for 4 units of time. Function 0, the initial call, resumes execution, then immediately calls itself again. Okay, but what about this one in between? I think that might be why I got so many downvotes. I think this explanation was missing this one in between. Oh no. Oh, what? Wait, I think this is supposed to be end at 6, not end at 5. This is really 3 units it would be going for. That's really confusing. 2, 5. Oh, I guess it's the. That's also really confusing. So if you end at 5, you don't end at the beginning of 5. You end at the end of 5. So this is inclusive. So it is 5 units. Oh man. Okay. 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 So then it says you immediately calls itself after ending at 5. Calls itself again. Okay, I see. I get it now. So end it start. So first call, first call, recursive call ends. Next call start. Another recursive call starts. Another recursive call ends for 1 unit, and then finally the first call initially ends at 7. All right. Excuse me. I think I get it. So that'll give you 2 here plus 4. So now what's weird is this 0 to 2 is indeed should be 3, right? Well, you're starting at 2. See, that's the thing. That plus or minus beginning and end thing going on is a sort of off by 1 sort of thing is that's very confusing. So you have 2, and then from here you have 2, and then from here you have start it right. So you have 2. You start a recursive call. No, not this one. Start at 2, 0. Have a recursive call at 2. Go until the end of 5, which is the beginning of 6. It really should just be 6. Yeah, it's so confusing. But yeah, that's actually really confusing. I think that's the part that's probably the most confusing. So when you're ending, you're actually ending at like sort of after 5. So you get 2 units here. You get 4 units here. This takes you really to 6. You start immediately again at 6. And end at 6 1 unit later. So we said this is plus 2 plus 4 plus 1 to 6, and then this initial one at the beginning is another plus 1. So plus 2 plus 4 plus 1 plus 1. 4 plus 2 plus 1 plus 1 is 8. Yeah. Okay. Oh, that is. Oh, come on. Great. Okay. And I guess we assume that things are ordered in such a way where they start the end for each function happens in time later than the beginning. I wonder if we need to sort these things by time as well. I'm kind of thinking about that, wondering about that. This is a very confusing problem, but I get it. I think I understand it. So you have one function again, start at 0, end at 2. Oh, we did that. We did that already. So 2 functions now, start at 0, start at 2. So now you have 2 at 0, and then we're recursively go for another 4. So we're at 6 for 0. We end that. Then we start the next call. So this is, we got 6 total here. Start the next call at 6, end it at 6, so we get 1 at that first function, and then we go back to the first call, which gives us another 1, so you have 7 and 1 as described, or as expected. Okay, interesting. Starts at the beginning of time 0, executes for 2 units of time, and recursively calls itself. Function 0 recursive call starts at the beginning of time 2 and executes for 4 units of time. Function 0 initial call resumes execution, then immediately calls function 1. Function 1 starts at the beginning of time 6, executes 1 units of time, and ends at the end of time 6. Function 1 starts at the beginning of time 6, executes 1 unit of time, and ends at the end of time 6. Yeah. So the beginning of time 6 and the end of time 6, I think it's just not a great way to organize this. I think you really should. This should be designed that each starting ending point should just be the same number. You shouldn't have the starting point start 1 unit before the ending point. That's really what's going on here. There's two different timelines. One is for the starting times, which are 0 through 6, and the ending times are 1 unit forward, 1 through 7, which makes things way more confusing than it should be. I think that's probably why this got a lot of downvotes. It's just kind of poorly designed. I mean, the question itself is maybe intended to kind of, put you through that difficulty, but in practice, I wouldn't design it that way. It seems really bad. Okay. All right, and then you have n equals 2. Start at 0. Start at 2. That gives you 2 units. Then end at 5. So that's the first call, or it's called function 0. That gives you another 4 units, so you end up with 6 for 0. Then you start at 7, so actually you go back to 0. So you end up, the end of 5 is really the beginning of 6. And starting at 7, you actually go 1 more unit. So you do 1 more unit for 0. So you get, here it's really sort of goes all the way until the next function at unit 1, or at the first call. And that would put you at, starting at 7, that would give you 7 units for 1. And then you add, I guess you add another unit later. Yeah, so 7 units for 1, 1 unit more for 1, or 7 units for function 0, 1 unit for function 1, and then 1 more unit for function 0, which puts you at 8 and 1 as desired. Okay, and then finally here, starting and ending in the same slot, you get 1. So that's ridiculously confusing. I think, quite frankly, I would outright just convert the end times, their time differences, just slide them over 1 to the left, and then that way you could just take the difference between, like 1 and 0 would be 1 unit, and 0 and 2, and actually just lock all of the units on the left side and keep it simple. Yeah, I think that's the way to do it. So n is between 1 and 100. So log's length is 500. And then function IDs between 0 and n, excluding n, which is interesting. And then, so actually a few things to say about this. And then you have timestamps between 0 and a billion. Whoa, okay. No 2 start events will happen at the same timestamp. No 2 end events will happen at the same timestamp. Each function has an end log for each start log. Okay, yeah, that's good. So you need these assumptions. Okay, so pretty interesting question. Took me 20 minutes just to read it and understand it. No kidding. I think that's probably why I got so many downvotes. It's just a hard question to deal with. What we're going to do is have a return vector, and the size of that return vector is going to be n, 0. We're going to use that as something of a hash map. Each log we can parse, I think, just split over the semicolon or the colon tokens. I think what we're going to do is we're actually going to convert artificially, when we parse, we're going to convert the end time to, we're going to subtract 1, so the end time actually matches with the start time. Excuse me. So if you end at 5, actually I think you add 1 really to the end times. So yeah, so if you, so we're going to add 1 to all the end times. So that way if you end at 5, so 1 starts at 2, it's going to be the start here, and you're actually going to end, instead of ending at 5, you end at 6. And it's going to be the start of 6, end of 6, the same spot. So that'll be 6 minus 2 is 4. Right, so the math is simple and we understand it. And we're not utterly confused. And I mean, ultimately, one thing is we don't know if the logs are sorted in such a way where this stack is kind of set nicely. I think that's one issue. But basically, you can. So this is kind of challenging. This should be sorted in terms of the second variable, actually. Like, that's what we should probably do. We should probably parse all the logs. And there's only 100 of these items, so it's actually, yeah, 500 logs and 100 items. So we can kind of do whatever like processing we need to do or want to do. So I think the best thing to do would be sort first by, it should be by the timestamps, and then second start by start and end, where start should come before end, because you can, in theory, you can end, and where the end times we're going to add +1 when we parse, because the end times in theory could be, I guess, the same time. Well, no, I mean, yeah, we want the start times to come before the end times if we have the same timestamp. I'm just thinking, like, how do you even think about this problem? I don't know. I don't have the solution. I don't know. One of the tricky problems with this is that, yeah, the order that you get these in are not necessarily the right order. Like, you can get these in the input data could be fed to you in multiple different ways, but the actual meaning of the logs of the data. So there's that. I mean, that's really confusing. But I think it needs to be sorted by the timestamps, right? Like, ultimately. Can you have like illogical things where you end a function? That's the next question. Do the end times always come after the? Really, the only time that matters is if you're dealing with these end times and start times. They only matter if you're dealing with a situation where the timestamps are the same, and that means something's starting and ending at the same point, which is fine. But the ending, actually, in that situation, the ending should come first, because that's very confusing. Yeah, could you believe that? So the end time should actually come before the start times. What's weird about that too is you can end a process like a recursive, so that's also kind of illogical, but technically could happen if you have, like, not a recursive call, but function 0 and function 1, and function 1 could end at the same time, or function 0 could end at the same time function 1 ends, or function 0 could end before function 1 ends. So function 1 starts, function 0 starts, function 1 starts, and then function 0 ends. Presumably we want it to end after function 1 ends, but it could actually have ended before function 1, and then what do we do in that case? Actually, let's test that. Let's see what they come up with. Let's see what they say. Let's actually find out. So if this was an interview, I'd ask that question, but it would be very kind of a confusing thing to ask. It'd be like, again, this is like a kind of hard question just to comprehend. So let's do that. Let's do two functions. First function starts, next function starts, one after it. The first function, or function 0 ends before, so we'll put 2, and then yeah, the function 0 ends before the function 1 ends, and then function 1 ends sometime after that, which is going to be, so ending at 2 gives you, actually would be 3, and then ending at, let's say, 5 actually would be 6. So what does this give us? What do we expect for the second one? Invalid test case, assertion error. Okay. And okay, so what if we end this way after, like 7? How about that? First off, does that give you an assertion error? And second, it's still an invalid test case. Okay. So this does need to come afterwards. I think the timestamps need to be sorted. That's the first thing. I think the timestamps need to be sorted, and then. Okay, that's interesting. All right, so this is not too bad. So, okay, in that case, I think this is a relatively easy question. Just took forever to understand what they're asking. So you're not going to have a test case where, first off, the timestamps are out of order, right? The timestamps are going to be in sorted order. That's the first thing. Second thing, the start and then end. You're going to end the function that's currently active before you end the other functions on the stack. So I think this is supposed to be modeled by a stack, more or less, which is fine. Yeah, this is relatively easy to model this with a stack then. We don't have to do any sorting on the logs first. So, okay, so we can say for string, string s in logs, we're going to parse log line. Actually, we don't need any of those things. Parse log line, we're going to say const standard string s, and we're going to take, no, we don't need that again. We're going to say, how do we want to do this? So we'd say parse int first, int integer first. So we'll just say for, we're going to manually parse, I think. I is less than I is less than string.size plus I and I, we're going to say s of I is not equal to colon. We're going to say character c equals s of I. We're going to say int or digit equals s of I minus 0. We're going to say first equals 10 times first plus digit. Parse the start or end token. Next, we're going to say again for I is less than s.size, and s of I is not equal to this token plus I. I'm not going to write a routine that just splits on this token. We could do that, to split this into strings and then convert two of the strings to integers, but we're not going to do that. But we could. That's another way. Token, and actually we're going to do string stream. Token of s of I. We're going to say standard string ret token, and we're actually going to return a tuple. So return token is token.string, and then you can actually clear this. We're not going to bother clearing that though, it's going to get deallocated after we're done. Parse another integer. This is maybe not the best way to do this, by the way, to parse. Yeah, I guess at this point it's just I is less than, this just goes off the end at the end here. And we'll say int second 0, digit s of I minus 0, second equals 10 times second plus digit. Okay. Alrighty, now we're going to return standard make tuple of first ret token, and second. Now we said we're going to add 1 to the second, 1 to the second integer, order to ensure the function bounds line up. Yeah, we'll just say the bounds line up. Oops. All right, that should be fine. So now what we can do is we can parse our log line. We'll just do auto t parse log line, and then we actually can do, you can actually do const auto. This is timestamp, so f or n or id. Let's do id token stamp or time t. Yeah, we can do it this way. Of s, and I think the syntax works, right? Hopefully they have a compiler that'll compile this. This is basically like destructuring, and the syntax works in C++, the earlier or newer versions of C++. So how are we doing on time? Yeah, half an hour. Okay. All right. So what's interesting here is we would say, so we can have we could use a stack, I suppose. We really don't even need a. Yeah, I guess maybe we do need. Yeah, we could use a stack. That's fine. We're gonna use a vector instead of a stack. I guess we'll do integers. Sure, that's fine. We'll just go current stack. So if token equals start, then we're going to push onto the stack. Push back, we'll use the ID. And I guess we could put the ID and the time. Yeah, I mean, we could actually put the time. We don't even need to use the ID. We could really just use the time. Else if token equals end, and we're going to int equals int start time equals, now actually I don't know, does that make sense? Maybe we should do this differently. I'm thinking we push the start time. Once we see another start time, we can, it's actually really awkward. I don't even think we need a stack to do this. I'm thinking about it. No, we do. You do need a stack, because when you pop, you want to know what's below function that we're returning to. So we do want a stack, but I guess we just need like a previous time, really. We don't even need a start time. We just need we don't even need the, yeah, we don't even need that. We just need like the previous function ID, I think. Does that make sense? So if we push under the start, and we'll say, int previous time 0, and we'll say pushback. So we say if current stack dot empty. I didn't even talk about like what the design of this algorithm might be. So if the current stack is empty, then if the current stack is not empty, then we want to update what's on top of the stack. We're going to update that ID. So we're going to say ret of current stack dot, really should be peak or top. And we're going to plus equals that with, it's going to be the difference between this starting time, t, and our previous time. So, yeah, so if we're not empty, then we want to take what's at the top, and we're gonna say we're gonna add all the time there, and then also I'm thinking 0 to 2, is that 2 units? the start, yeah, that's fine. And then we're going to push the next function on there. If we're not empty. If we're empty, then we push the first function, and that's that. And yeah, and then we push, the previous time we set that equal to t, right, the last thing that happened. And actually I think you do that every time, no matter what, regardless of the token. So the next idea is you push, okay, you see an end. So yeah, you could either start something empty, you start the next thing, you're going to take whatever's on top of the stack and you're going to increment the time for that. Whether it's recursive or not, it'll be the correct function that gets that time. When you end though, you're going to take similarly the function that just ended, which should be at the top of the stack. Same deal, t minus previous time, and you're also going to update the previous time, but you're also going to pop the stack as well. And we guarantee that there's always going to be a top and a pop there when you have an end. I think this is all you need, and then you can just return ret. Something really simple like this. I think it's that simple. I don't actually know. I'm not really sure. I don't know. Let's see. What do we push on the back? Oh, pop back it should be. And then last is it's not top. Yeah, because we're not actually using a stat class. We're using a back. It would be we're using a vector. Start. Warning. Whoa. Multi-character constant. Oh, okay. I'm using too much. Using too many scripting languages lately, or programming too much in scripting languages where you can use either one, quoted or double quoted strings. How are we doing? 37 minutes? No top. Oh yeah, okay. The back. All right, let's see. How are we doing? Wrong. Nice. 0, 0. Okay, interesting. Really? Huh. Wow. What? Okay. Let's see this here. Maybe our parsing is wrong. Whoa. That's definitely wrong. Definitely wrong. That's interesting. So, I think move past the delimiter. I think that might be why. Tend to forget to do that. Yeah. Once it's equal, yeah, if it's not equal, this breaks immediately. Yeah, okay. Actually, you need to do this twice, right? Because it'll stop when I is on the. Oh no, that's fine. Just once. That is a subtlety. That is quite the subtlety. That might be the problem. Okay, there we go. That's parsing correctly now. We get 3, 3 and 3, 4 instead of 3, 4 and 3, 5. Oof. And why might that be the case? That's a good question. Okay, well. So if we run this code, it's close, but not quite. So the second function isn't getting what it's supposed to get. Okay. Starts at 2, ends at 6. 6 minus 2 is 4. Why do we get 3? initially here, pushback ID 0, C1, 2 minus 0 is 2. Then you see the end 6. 6 minus 2 should be 4. Previous time should be at 2. We see this end back. It's 1 pop. So T should be 6 here. Which I think is what we had before, right? Print that out again. Oh, wait, why is oh, that's why. Duh, that's my mistake. That's my mistake. When the token is the end token. Yeah, so you just say second equals well, just do if. There we go. I did that wrong. How are we doing on time? Yeah, 40 minutes. Okay. All right. I think this is right now. Let's go for it. It's probably wrong. It's probably wrong. Nope, it's correct. There you go. Not bad. All right, took a while. Yeah, that was kind of a challenging question just to figure out what they're talking about. 30 milliseconds, not the fastest. This apparently could be faster. I actually don't know how to make this much faster, really. I mean, the parsing is kind of, the parsing is pretty quick, actually. This is about as fast as it goes with the parsing, with regard to parsing. I could maybe loop the parsing code in. I'm pretty sure string stream is about as like, I think this is about as quick as it goes. Maybe I need to do this. Maybe I'm wrong about this being faster. Maybe that's one of the issues. Should be pretty quick. All right, let's go for it. Still pretty slow. Yeah, I don't know. Yeah, I mean, you can inline this right here if you wanted to. This is probably about as quick as you can go, though, as far as parsing this. I mean, this is pretty direct parsing. There's actually a lot of assumptions being made here too, where we're assuming that, you know, that the format's correct, more or less. Like, we're relying on a correct format to do this parsing as well. So that makes it a little bit faster too. I mean, there's an if statement here. Maybe we can get rid of one branch. Yeah, actually we can. We can get rid of one branch. We can also make this just an else instead of an else if. And the previous time, if it's an end, we can add we can add this logic to change the decrement here. Form this later in the code. I kind of prefer to do it here, but we can do it here, down here too. So when you're subtracting, you can update t basically. You could just ++ t here. See if that works. Oh. Okay, can't be constant anymore. Not constant anymore. Alright, still works. Let's go for it. Is it faster? If it's not faster, we should go back to what we had. Oh, it is a lot faster. Yep. There you go. Thought maybe that would be a little bit faster. You take one branch out here, and then you don't do a routine inside here. So I don't know. We're like mincing rice here. I guess I don't even know what the expression is here. We are beating a dead horse. Yeah, we're overdoing it. We don't need to go to such extremes. I don't know I don't know what the expression is, but we don't need to go such extremes here, because we're only saving 14 milliseconds, which, yeah, for something like this, it really doesn't matter that much. All right, sweet. So yeah, there you go. That's that one. Interesting question. Is there a faster way to do this? I don't know. This is probably about as fast as you can do it, I think, as efficiently as you can. Yeah, because you're returning an array of size n anyway, so you're at least O of n time no matter what. And then you need to parse the logs. You do need to go through every one of these. This does go linear, perform linear parsing of the logs, and the stack is proportional to the log size anyway. So you're using O of n. You need to use O of n memory, and I think you need to use O of logs memory for the stack. But I think you'll need to use the stack anyway to do this properly. Yeah, I don't really see another way of doing this, quite frankly. Yeah, feel free to let me know if I'm wrong about that, by the way, those of you who think there's a better way. Let's do this. I'm just curious to see how much of that speed up was from the removing that one branch. Yeah, quite the speed up. Okay, we'll go back. That's fine. Oh wow. Okay, that was a big deal. All right. Anyway, okay. So thank you for watching. I will talk to you soon. Have a good rest of your day. That'll be that problem for now. I don't know what I'm doing. I don't know what to do. Actually, I don't know what I'm gonna do. I may or may not solve another problem before bed. Okay. Take care. Bye.